Ever get that feeling like when you're studying that physics is playing by like totally different rules than other subjects?
Mhm.
Like biology, you can get by with some good old-fashioned memorization, right? In chemistry, at least it tries to, build on itself logically for a while at least.
Yeah.
But physics, it's like it's out to get you. Like it wants to see you sweat a little.
hmm
This deep dive, it's for all of you out there who get that feeling. A while back, you sent us like a ton of articles on why physics seems so much harder than everything else. And honestly, you're really onto something. We've
Yeah.
all been there, right? Staring at those equations like they hold like the secrets of the universe.
Right.
Which, I mean, maybe they do, but you'd think they'd make it a little easier to crack the code. Our main source today is this article from scitechgen.com. It's called Why is Physics So Hard?
Okay.
And SciTechGen, they're all about, breaking down science and tech stuff, so hopefully they have some answers for us.
Yeah.
So before we really dive into the nitty-gritty here, I'm curious from your perspective, is it true? Is physics really just hardy to wrap your head around? Or is that just like a thing we tell ourselves so we don't feel bad about, not acing every physics test?
I think there's something to be said about physics that really, trips people up. And this article, it goes right to that point, like right off the bat.
Sure.
It's not just about, memorizing facts and figures. Like biology. Biology throws a lot of facts at you.
It does.
But with physics, it's more about really understanding how things work at like a deeper level,
Yeah.
like those fundamental principles.
Okay, so less like memorizing a phone book and more like what? Learning a new language, maybe?
Exactly.
Okay.
You've got to connect like experiments with actual theory. You have to figure out what those graphs are really telling you. And then on top of all of that, you've got the math to contend with.
Yeah.
It's a real workout for your brain, that's for sure. Not just a spectator sport, physics.
You were preaching to the choir here. I distinctly remember, like, really trying to understand how derivatives connect to velocity.
Right.
I felt like the more I learned, the less I understood about, well, everything.
Yeah.
The article, I think it mentioned something about this, didn't it?
It did. And it actually highlights a really important point. Physics, it's cumulative, which
Yeah.
means it builds on itself relentlessly.
Okay.
Like think about, learning a new language. You got to master that grammar. You got to have the vocabulary down so you can actually like form sentences, right?
Right.
Physics is pretty similar. Those
Yeah.
like those aha moments you have along the way, those are your building blocks. You miss a few of those, and the whole tower starts to wobble.
It really is. It's like trying to jump into algebra when you're, like, still wrapping your head around, like, what? Basic arithmetic?
Yeah, exactly.
Doesn't really work.
And, to keep like really digging into this whole why is physics so hard thing, the article makes another really good point. They say that a lot of times it's not taught in a way that actually makes intuitive sense. Like instead of starting with those aha moments, like those connections to the real world, it gets like bogged down in, memorizing formulas and equations that feel kind of, I don't know, sterile.
So it's not just us.
Right.
There is some truth to this idea that, like, maybe physics could be taught in a way that makes it, a little less painful, a little more accessible.
Absolutely. And the article actually makes a really strong case for that. But here's the good news. They also say that physics can be, like, downright engaging, even, like, fascinating.
Okay, good.
It's just about finding the right approach.
Right. Okay. All right. I'm ready for like a little dose of optimism here. How do we actually do that? How do we make physics a little less of a headache for everyone?
Well, the article, they have some solid advice, actually. First and foremost, they say you got to master those fundamental concepts.
Yeah.
Like really get them down. And that means like tackling those misconceptions head on. And then from there, they talk about how important it is to practice with what they call application-oriented problems.
Okay.
Instead of just, memorizing all those formulas.
Application-oriented problems, that's a phrase I'm ready to unpack a little bit. That sounds promising, but what does that actually look like in practice?
So think about it this way. A traditional physics problem might like ask you to calculate the trajectory of, I don't know, a ball, given its initial velocity and launch angle, right?
Right.
Pretty straightforward stuff.
Yeah.
Maybe a little dry.
A little bit.
But an application-oriented problem, that might ask you to, like, design a pitching machine.
Okay, now we're talking. That consistently throws a curveball.
Uh-huh.
And you'd have to factor in things like spin and air resistance and all of that.
Okay, yeah, that's way more interesting. You're actually using physics to, like, solve a real-world problem.
Exactly. And when you do that, you're not just, plugging numbers into an equation.
Yeah.
You're really developing like a deeper understanding of how those concepts actually work in the real world.
Right.
You're making those connections, and that's what really helps physics to like click. The article, actually, they give this like fantastic example of this with
Don't leave us hanging. What's the example?
roller coasters.
Okay.
They use roller coasters as an example. So instead of just like doing the standard physics problem of here's the roller coaster,
Yeah.
calculate the potential and kinetic energy at these different points.
Yeah.
They talk about, like, imagine you're actually designing a roller coaster, right?
Right.
And you want to make it as, thrilling as possible for the riders. But obviously, it has to be safe.
Yeah.
So you've got to factor in all these different forces, gravity,
Mhm.
inertia, even like what materials you're using to build the coaster.
Wow.
All of that stuff plays a role.
See, now that's what I'm talking about. It's like, it's the difference between like reading a recipe and actually like baking a cake.
Yeah.
Right.
Exactly.
Suddenly all those like formulas and concepts, they have a purpose.
Right, exactly. And speaking of like purpose and application,
Mhm.
the article also talks about how important it is to really, strengthen those math skills as you're learning physics,
Okay.
particularly calculus.
All right. Back to calculus. I feel like we could do a whole nother deep dive on just like calculus and why it's useful.
Totally.
But for now, can you give us like a quick example of how calculus actually shows up in physics? Like, how are they connected?
Sure, yeah. So imagine you're trying to like describe the speed of a car that's accelerating.
Okay.
Basic algebra that can tell you the average speed over like a certain amount of time.
Right.
But what if you want to know the speed at like one specific instant?
Okay. Yeah.
That's where you need calculus. Because calculus gives you the tools to actually deal with, values that are constantly changing,
Right.
like instantaneous velocity.
It's all starting to come together now.
Yeah.
I'm starting to think that maybe my physics teachers were right when they said this stuff was actually useful in the real world.
It really is. It's all about, finding those connections and,
Yeah.
and appreciating like the power of physics to actually help us understand the world around us, right?
It is. And for our listener who inspired this whole deep dive, I hope you're feeling, I don't know, maybe a little more optimistic about tackling physics.
Yeah.
Because it's not about being a natural,
Right.
it's about finding those approaches that click for you and just like embracing the challenge.
Absolutely. And on that note, the article ends with, I think, a really great question they ask. What aspect of physics do you find most intriguing or challenging, for that matter?
Ooh, good question.
So let us know. We'd love to hear your thoughts.
Yes. Keep those brains buzzing out there, and we'll catch you next time on The Deep Dive.